Okay, cool. All right. So let's go here to the PowerPoint. And let's go. So this was all kind of the first bit, which was last week. Is everybody good on that?
Yeah.
Everybody's feeling good on simple Punnett squares?
Yeah, I'm chilling.
Okay.
Yeah.
I feel like you guys do a lot of those in middle school. So I'm not too concerned about that. Have you all done 2 trait crosses yet or not yet?
Yeah.
You have.
Oh wait. I don't know.
Okay. If you don't know, then you probably haven't. So that's what we're going to focus on today. But there were a couple of things that I wanted to talk about before that, just things that are kind of exceptions to the rule. So one of the things that we'll do, and I'll put some stuff out, is kind of look at our own traits and see if we have dominant or recessive traits. So one of the things we always talk about is tongue rolling. That is a dominant trait. So if you can't do this or can't do this, then you are homozygous recessive. You have 2 copies of the recessive trait.
Can you, Miss Bigelow?
I can, yeah.
Good.
And we'll talk about a few more kind of interesting things that we can look at on ourselves. But for this, first, I want to talk about 2 things. I want to talk about incomplete dominance, which you can also refer to as intermediate inheritance. In genetics, we tend to always assume that it's either dominant or recessive, but it's important to note that you can have situations where you get a mix of the 2 traits. So let's say flower color, right? Red and white won't necessarily give you red or white, but can give you pink. So this would have to be homozygous dominant. This would be homozygous recessive, which would make all of that first generation heterozygous. So 1 dominant, 1 recessive, that would give you pink. If you were to breed 2 pink plants together, then this would be what you call your F2 generation, so that next generation. And that would give you 1 homozygous dominant, 2 heterozygous, and 1 homozygous recessive. Does that make sense?
Yeah.
Yeah.
Okay. The other thing, and this we'll talk a little bit about next week, because next week we'll be finishing up the genetics unit, something called co-dominance, where you can actually have traits that are co-dominant to each other, meaning 2 alleles can be expressed. Neither is dominant or recessive to the other, and they don't blend. So you won't get a mix. You can actually have 2 different alleles expressed. Can anybody think of an example of what that might, where you might see that in a human?
There's a condition where you can have 2 eye colors.
That is true. I don't know if that's co-dominance. I'm not sure. I'll have to look that up.
Okay, Hazard. Hey, bud.
Why, Danny, you have 2 different color eyes?
No, I don't.
Okay. Can anybody think of an example, like a very common example in humans where you have 2 dominant?
Lefty, righty?
Oh, ambidextrous. That's not the example that I'm thinking of, but that could be an example of that.
If you're double jointed, you're only double jointed in 7 joints. So.
I don't know if that might be due to a few different things. Does anybody in here know their blood type?
Oh, is it when AB? Is that AB? Is that
Yeah, exactly. Yep. So blood typing. is a good example of co-dominance, because you can be, well, you could be type O, right? You could be type A, you could be type B, you could also be type AB. A and B are co-dominant to each other.
Is that common?
It is. Yep. It's common. I think O is the rarest and A is the most common. And the other two are like in the middle. But yeah, it just depends on what alleles you end up with from your parents. So if you have one parent that's a type A, one parent that's a type B, offspring could be type A or type B or type AB. Depends on the genetics of the parents. And we are going to go over that in detail next week, because doing Punnett squares for that is different. So we'll work on that next week. But I always just kind of like to bring that up. You can also see this in animals with fur color, right? You could have like a white cat and a black cat give you a white cat, a black cat, or a cat where they have everything. And then kind of the last weird thing for us to talk about is something called polygenic inheritance, meaning poly, many genes. So one trait that is determined by multiple genes. Height, skin color, eye color are all considered to be polygenic because they are determined by more than one allele. So this is just an example of how that might look in a Punnett square. For skin color. Eye color, I think, is determined, I was reading, it's determined by 8 different genes. So that's why, you know, you can have a brown-eyed parent, a blue-eyed parent, and then the kid can be anywhere in the middle there. Does that make sense, guys?
Yep.
Okay. All right, so this is mainly what I want to talk about today, which are dihybrid crosses. This is where you do a Punnett square where you're tracking 2 separate characteristics. Now, remember, the law of independent assortment tells us that traits are not connected. They travel separately. So when you're looking at a cross with 2 different characteristics, the hardest part is figuring out what the alleles are going to look like from each parent. This is a very confusing way to look at it, but there are some really nice ways. So let me go to the Bio Ninja. Oops. Bio Ninja. Okay. So this is a really nice resource for this. When you're looking at one trait, you have 2 different alleles that you're looking at. When you're looking at 2 different characteristics, I should say, that are unlinked, you end up with 4 different allele possibilities for each parent. Does that make sense?
Yes.
Okay. So this is basically where you do a FOIL, like you would do in math. This is going to be a Punnett square. It's going to be an 16 box Punnett square. There are going to be 8 alleles in total, 4 from mom, 4 from dad. And the first thing that you need to do is figure out what your alleles are going to be. So let's see here. Okay, so this is a nice example. Here is your dihybrid cross Punnett square. 4 alleles on the top from the female, 4 alleles on the side from the male, gives you 16 boxes and 16 different combinations of what you're looking at. So these are your parents. Homozygous dominant for both, homozygous recessive for both. Let's say this was all blank, right? The first thing you would need to do is figure out your alleles. So let me go back to BioNinja. Okay. So let's look at this one, right? Let's say you have a parent that you want to do a cross on, and this is the genotype, heterozygous and heterozygous for both traits. When you want to set up your gametes, you FOIL. So you're basically separating where you have an A and a B for each one, not an A and an A and a B and a B. So you multiply this one with the first, and then you multiply this one with the outer. That gives you AB, right? AB and AB. Then you do this one in, right? A to B, which gives you that, and A to B, which gives you this one. Does that make sense?
Mm-hmm.
And is that similar to what you do in math for things? If it's
Yeah.
not, it's okay. I haven't taken a math class since the 90s, so feel free to tell
Yeah,
me.
it's kind of like that.
Okay.
Good job,
There's this method too, the claw method. I've never really used that. I think FOIL is just kind of the best one to do. Okay. And then you would put that parent on one side of your square and do the gametes for your other parent. So let's come down this way. I know it's exhausting, right? Okay. So here's some peas, which is a nice example because we use peas a lot. Okay. So this looks like it's a cross of this to itself, right? So you have big Y, big R, little r. These are your gametes. These are your gametes. And then you multiply, just like in a regular Punnett square. So big Y, big R gives you that. And then little y, little r gives you that. What do you guys think?
It's not bad.
Yeah.
Not bad. Okay, good. I gave you guys a lot of good resources. The BioNinja is excellent. This is one of the things that I gave you to read. I think this outlines the FOIL method to find the gametes really nicely. That is the thing that everybody struggles with. Not everybody, but a lot of people struggle with, like on assessments and stuff, tests, quizzes. You have to make your gametes first. Once you get your gametes set up, the rest is, I think, I don't want to say easy, but not terrible. Okay. How are we doing?
Good.
Feeling okay about this?
Yeah.
Yeah.
Okay, good.
Yep.
All right. And again, I would say work on these practice problems. You know what? Let's go through one right now and see how we do. And then you guys will be, I think, pretty set for doing all of your work. And we have about 5 minutes left if we're sticking to our time. Okay, in sheep, the allele for black wool, which is big B, is dominant over white wool, little b. Horns is dominant over hornless, so big H, little h. Pure breeding horned sheep with black wool. So if you have a purebred horned black sheep, what is its genotype?
Capital H, capital H.
That is correct. And there's going to be two characteristics in the genotype. So horned is big H, big H. What about the color?
Oh, black wool, capital B, capital B.
That's right. So you could put B first, you can put H first, it doesn't matter. Ooh, ouchie. I'm going to do the B's first. So I'm going to say big B, big H, big H. That sheep was crossed with purebred hornless white. So what is the genotype for that? White hornless. What's the genotype? B first. Big or little?
Little.
Yep, 1 or 2.
2.
Yep, and what about the H? Same?
Yes.
Yes. Okay.
Is there always two?
Say that again?
Is there always two?
For a dihybrid cross, yeah, there will always be 2.
Good.
Okay, state the genotype and the phenotype of the F1 individuals. So genotype is their letters, phenotype is how they look. Let's do this cross. I'll give you guys like 2 minutes to do the cross and figure this out. Okay,
Wait,
so
it's not a Punnett square, right?
it is a Punnett square. I mean,
Oh, it is?
for this one, because of the genotypes of the parents, for the first one, I wouldn't need to do a Punnett square, but I always encourage people, even if you think you know the answer, do the Punnett square because it's just good practice. So let's do A first, genotype and phenotype of F1 individuals. So you have to figure out your gametes. What are you barking at? Okay. So when you guys are ready, just let me know.
Ready?
Ready?
Yep.
I can wait a minute for those who are not. Okay, are you guys ready to say what's going to be the genotype of the individuals in this cross? Just yell it out if you know. Genotype.
Um.
So you're crossing 2 homozygous individuals. So 100% of your offspring are going to be what?
Black.
Yes, and?
And they're gonna have horns.
That's right. Heterozygous or homozygous for both?
Wait, say it again.
Heterozygous or homozygous for those traits?
Oh, it's which one is it? I don't remember.
That's okay. You're going to
Hold on.
have 100% of your offspring is going to be heterozygous for both traits. Once we do the second part, I'll click on it and all the answers will pop up. So if you're mating 2 F1 offspring, right? So both heterozygous for each trait, figure out your gametes and do your cross and try to figure out the expected ratio of phenotypes. So just how they look.
Okay. Oh, it's
This takes a while. I'm doing this on the tiniest piece of paper. I don't know why. This is a tricky one because all the letters are different, so you really have to calculate every square. Okay. Now this should be, Aha, yes. Okay. Do you have it? You guys have it? If you don't, it's okay.
No.
I don't think it's right, but because you're mating two.
Two heterozygous for both traits. Let's see. Are you guys ready to see the answer, or you want to wait a minute? We can wait. Yes. Okay.
Wait,
Are
two
we ready?
heterozygous, which would make it. Wouldn't it be not 50% for each?
The ratio of phenotypes. So not the genotypes, because that gets crazy, but the phenotypes. And when you cross two individuals that are heterozygous for both traits, you always kind of get the same ratio. Once you know the ratio, you kind of don't have to do the work, but you guys don't know it yet.
Wait, so the difference of finding a genotype versus a phenotype is what?
Genotype is the letters, it's the alleles. Phenotype is the physical appearance.
Oh, it's just the way that you say it once you get the actual answer.
Yep, exactly.
Right.
Okay, let's look at this. All right, so here's your parent generation. Your F1 generation will be 100% black and horned, but heterozygous. Then, when you breed two of these together, these are your gametes, and they're the same for both because both parents are the same. Your ratio is going to be 9, 3, 3, 1. Anytime you cross two heterozygous, I'm going to say double heterozygous because we're looking at two traits. Anytime you cross two double heterozygous individuals, you get 9. I don't know. 9 black horn. Now that doesn't mean they all have to be homozygous for both traits. This is a black horned one as well. 9 black horned, 3 black hornless, 3 white horned, 1 white and hornless. Does that make sense?
Yeah.
Okay. What are your questions? Do you need to get, I have batteries, bud, if you need batteries.
How did you find out the letters to set up the table?
To set up this table?
Yeah.
Okay. So these are the offspring. I wish I had my little pen to write on my screen. Of course, it's in my desk drawer at school. When you cross two of these, you make your gametes. So big B, big H is the first. Big B, little h is the second. Little b, big H, and then little b, little h.
Oh, that was the foiling.
Yeah, you have to foil these to find your gametes. And then all you have to do is multiply them. So big B, big B, big H, big H, big B, little h, big H. And then what I always do, just for like organization and keeping things straight, even though it's BH and BH, put your B's together, put your H's together, always put your dominant one first. Even if it's like little h, big H, always put the big one first, just
Okay.
to help keep yourself organized. Yes.
A question.
What's your question?
Guys, a little more.
Yes. Can you give me 1 minute, please?
I need on the phone right now.
I'll be right with you.
Hold on.
Wait, you first look at it as like
Oh my God.
the
I
B
gotta
is
get out of
dominant
my
in the
snack.
first one, so it's gonna be big B, little b, and then the H is dominant in the
I'm here.
color or
Whoa,
the
whoa,
horn.
I'll be
So it'd
here.
be-
You can hear. Sorry, can you say that one more time?
So you start by seeing that like the color was the black was dominant, so it's gonna be big B, little b, and then you see that the horns were dominant, so it's gonna be big H, little h, and then using that you foil that to find what the next generation would be.
That's right. Well, you foil to find the gametes. So
Oh yeah.
first you do first, outside, inside. However, whatever makes sense for you. Can you please give that to me? Thank you.
Okay.
Yeah, and then once you have your gametes, you put them in your cross, and you do your multiplication essentially to figure out what your offspring is going to be. And then once you have that, you work out your ratios.
I can talk to you.
You can? You're going to teach them biology? That would be awesome.
Let's go talk to you.
Okay.
By my
And
So
then
how do you like find the ratios? Like, why is it 9?
why is it 9? Okay, well, let's count. So we're looking for black horned. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it doesn't have to be homozygous. It can be heterozygous too. So there's 9. Your black hornless is 1, 2,
Mom, just go get it.
3.
Mom, I go get my snack.
I will. Okay, 1 second. Your 3 white horned are 1, 2, 3, and then 1 white hornless. And anytime you do a cross like this, where you have 2 heterozygous, double heterozygous parents, your ratio is always going to be the same. It's always going to be 9, 3, 3, 1. And the questions, like test questions or whatever, will almost always ask you for the phenotypic ratio. So that'll be your answer, 9, 3, 3, 1. Okay. Does anybody else have questions on anything? What do you guys think?
No, I think we're good.
Okay. My advice would be go through your stuff, do the readings, watch the videos, start on your practice sheets. And I got to get that I have to figure out that SpongeBob one. And then when we have office hours Wednesday, we can come back together and go over anything, answer any questions that you have, and make sure we're good to go on this.
Okay.
Okay?
Mhm.
Does anybody have questions or anything before we wrap it up for the day?
Nope.
Okay. Did you guys like doing this in person, or would you rather have a screencast?
Either or.
Either or. Okay.
Yeah, I like screencast too, though.
Yeah, I'll probably do a screencast next week, for next week, because I think this was the most challenging part. So once we have this, everything else should flow kind of nicely.
Okay.
Okay.
Oh, okay, guys. Anything else you want to chat about before we wrap it up?
So you'll post this video?
Yeah, I'm going to post this video.
Okay.
Any other questions, comments? Okay. Yes. I need to go get the tiny tyrant a snack.
All right.
So, but if you guys, if you have more questions, I'm happy to answer them. If not, then send me an email, ask me questions. He's a hungry child. He never stops eating.
Give me my coffee. Give me eggs.
All right, guys. So if there's no other questions, have a good day.
My God, I'm going.
And I'll talk to you guys on Wednesday.
Yeah.
All right. Take care. Have a
All
good night.
right. Okay. Bye, guys.
Bye, Miss Bigelow.
Bye.
Good to see you.
Do you see the leprechaun?
I saw the leprechaun. You're so silly. Now I have to figure out how to stop recording. Wait, hold on. Stop touching. Stop touching. Stop touching.